Now let's go to example problems on hypothesis testing. But before that, let's have first these critical values. Now these are the most commonly used alpha or level of significance in the Z distribution. So these are the critical values for the Z distribution. If your alpha is 0.10 and it is left-tailed, so your negative Z alpha is equal to negative 1.28. If it's positive, then it's positive 1.28. Then if it is two-tailed, then it is plus and minus 1.645. The negative is for the left side, the positive is for the right side or right-tailed. Now, if your alpha is 0.05, then your left-tailed negative Z sub alpha or critical value is negative 1.645. If it's positive or right-tailed, then it is positive 1.645. But if it's two-tailed, then it is plus and minus 1.96. And last, 0.01, if your alpha is 0.01, then the left tail for this is negative 2.33, and the right tail for this is 2.33. But if it's two-tailed, then it is plus and minus 2.58. Problem number 1. A researcher reports that the average salary of company managers is more than 63,000. A sample of 35 managers has a mean salary of 65,700. At alpha 0.01, test the claim that the company managers earn more than 63,000 a month. The standard deviation of the population is 5,250. So let's start first with our null and alternative hypothesis. So HO and HA. Now the claim, test the claim that the company managers earn more than 63,000. So that is the claim. So take note of this. More than, the symbol for more than is greater than. And take note that this symbol is for the alternative hypothesis. Therefore, our mean here is greater than 63,000. This will be our alternative hypothesis. Thus, since the null hypothesis is the opposite of alternative hypothesis, you may write the null hypothesis as the mean is less than or equal to 63,000. Or you can just simply use the equal sign. So either of these two null hypotheses are acceptable. But take note that the alternative hypothesis is our basis for our critical region later. Next, the next step is to write down the alpha. Okay, our level of significance is given alpha at 0.01. It is given. Okay, and next is we need to know whether this is a T or a Z distribution. Now, take note that in order for us to know if it's a T or a Z distribution, we only need to know if n is greater than or equal to 30, or the population standard deviation is given for us to know that it is a Z test. Otherwise, it is a T test. Now, let's examine. N is equal to 35, and this one, the population standard deviation is given 5,250. This implies that this is a Z test. Okay, this is a Z test. Next, the next step is to know whether it is a left-tailed test, a right-tailed test, or a two-tailed test. If that is the case, then we will look at the alternative hypothesis. This is our alternative hypothesis. Our alternative hypothesis uses the symbol greater than. So this implies that this is a right-tailed test. Okay, so right-tailed test. So this is a right-tailed. Therefore, our critical region or critical value, so I will write it here, our critical value or CV is equal to, since this is one-tailed and it is right, so it is positive z sub alpha. Okay, z sub alpha. And take note, alpha at 0.01, so it's here at the bottom. And z alpha is 2.33. Therefore, this is 2.33 positive. So if we draw this one on a normal curve, so this is what happens. So this is the mean, or 0. So this is positive, so this is our critical value. So the critical value separates the unshaded region and the shaded region, or the rejection region and the non-rejection region, or acceptance region. Now take note, this is greater than, so the rejection region is this one. This is the rejection region. Okay, so that is our critical value, and this area here is our critical region. Next, we are going to compute for our z. So after getting the critical value and finding the critical region, we need to solve for our critical our z computed. So our z computed is x bar minus mean over the population standard deviation over square root of n. So our x bar, or the sample mean, is this one. A sample of 35 has a mean. So meaning this is our x bar. So this is our x bar, 65,700. And our mean, this one, the mu, this is found in your hypothesis. So whatever value you use here is our mean. Okay, so our mean, population mean here is 63,000. And then divide this by 5,250, the population standard deviation. And then divide this by square root of 35. So you may use your calculator. 65700 minus 63,000 divided by 5,250 divided by square root of 35. So this is 3.04, since this is a z-score, so 2 decimal places. So positive 3.04. Now look at this. We will compare now the critical value, which is 2.33, and our computed. Let's have this z sub c for z computed. Now let's draw this one in order for us to decide, make decision. Okay, let's make it bigger. Okay, so our critical value is 2.33, so it's somewhere here, 2.33, and this is our region, critical region. Now let's look at this. Let's locate 3.04. Positive 3.04 is here, right? It's greater than 2.33, so 3.04, right? Now, what will be our decision? So after comparing the z computed and the critical value, the next step is to make decision. So what will be your decision, or our decision? The decision is either to reject or to accept HO. Now, by just looking at this area here, our z computed falls within, no? It's inside the critical or the rejection region. So meaning, our decision here is to reject HO. Why? Because the Z computed, the 3.04, falls within the rejection region. Okay. So after the decision, so by the way, if you want to complete the statement, you may say reject HO since you may see Z sub C, or the Z computed, falls within the critical region or rejection region. Okay, so reject. And the last one is to make conclusion. Okay, so conclusion, since we reject HO, we reject this one. So our conclusion will be H sub A, right? Because if this is false, then this is true. So therefore, we may conclude that the company managers earn more than 63,000 a month. Okay, you may write it here. Therefore, the company managers earn more than 63,000 pesos a month. So that will be our conclusion, because we rejected the null hypothesis. So we concluded the alternative hypothesis. So that's why the company managers earn more than 63,000 a month. Okay, so let's go to example 2. The average baptismal cost includes 50 guests. A random sample of 32 baptismal during the past year in the NCR had a mean of 53 guests and a standard deviation of 10. Is there a sufficient evidence at the 0.05 level of significance that the average number of guests differs from the national average? So that is the question. So that is the question of this problem. So let's start first with our null hypothesis and our alternative hypothesis. So what will be our claim in this particular problem? So take note of the word differs. Okay, so we may say that the average number of guests differs from the national average. So that is, or that falls on what? The alternative hypothesis, because differs from, so there is a difference, right? So it means that that statement falls on the alternative hypothesis. So differs, so meaning they're not equal. So the national average is 50. Okay, the first statement, so 50 guests. Therefore, our null hypothesis for this one does not differ. So they're the same. So equal to 50. Next is our alpha. Our alpha is given the level of significance, the 0.05. And next is to determine whether it's a Z or a T test. So N is a random sample of 32. And of course, the standard deviation, or this is the sample. So the sample standard deviation is 10. Now take note, our N is 32. It is greater than or equal to 30. So this means that this is a Z test or a Z distribution. We'll use the Z distribution. Next is we need to determine whether it's a left-tailed, right-tailed, or two-tailed. In order for us to know that, we'll go back to our Alternative hypothesis. Our alternative hypothesis uses the symbol, the not equal. Therefore, this implies that this is a two-tailed test. Okay, this is a two-tailed test. Therefore, our critical value looks like this. The positive and negative z sub alpha over 2. So 0.05, so on the second row. So we have plus and minus 1.96. So plus and minus 1.96. So visually, we have this. This one is negative 1.96 for the negative side, and for the positive side, we have the positive 1.96. So these two are the critical values, and the shaded region are the rejection region. Okay, so since now we have the critical values and critical region, let's compute now the value of our z. So again, z computed is x bar minus the mean, and since we're given with the sample standard deviation and the square root of n. So x bar is the sample mean. So we have it here. A random of 32 during the past year had a mean, so 53. And then our mu that is used in the alternative and the hypothesis, we have the 50. So minus 50 divided by our sample standard deviation is 10 divided by square root of 32. So what is this equal to? You may use your calculator. 53 minus 50 divided by 10 divided by square root of 32. So the answer is 1.70. So rounded off to positive 1.70. Okay. What is next? The next thing is we need to compare the critical values and the critical values in the computed z value. So we have here 1.96 and negative 1.96. So this one, negative 1.96. Now let's locate 1.70. 1.70 is somewhere here. Okay. So now what is our decision? Is it reject HO or accept HO? So if you notice, the z computed does not fall within the critical region. So we may say, do not reject HO since z computed does not fall within the rejection region. So it's not within the rejection region. Okay, so therefore, what must be our conclusion? Okay, so our conclusion, so since we will not reject our HO, so we may say that the average baptismal guest, or the average number of guests, does not differ from the national average. The average number of guests does not differ from the national average. Okay. or you may have there is no sufficient evidence to support the claim that the average guest in a baptismal is not equal to 50. So you may have that or this one as your conclusion. Number 3, one of the undersecretary of the DOLE claims that the average salary of a civil engineer is 18,000. A sample of 19 civil engineers' salary has a mean of 17,350 and a standard deviation of 1,230. Is there enough evidence to reject the undersecretary's claim at 0.01? So again, let's start with the null and alternative hypothesis. So what is the claim of the undersecretary? So claims that the average salary of a civil engineer is 18,000. So is, that is, or that uses the symbol equal sign. So the claim falls on the null hypothesis. So the claim falls here. So 18,000. Thus, our alternative hypothesis is the complete opposite. So if that's equal, then we'll use the not equal. That is, the average salary of civil engineer is not equal to 18,000. Next is the alpha. Alpha is always given. We have 0.01. Then, is it T or Z? So let's examine. We have N is 19. And this is a sample standard deviation. So this is S. 1,230. This means that this is a T test. Okay, so this is a T test. Now, the next part is to determine whether it's a right-tailed, left-tailed, or a two-tailed test. So let's look at here. It uses the not equal symbol. So this is a two-tailed test. Two-tailed test. So therefore, our critical values here is the plus and minus T. Our alpha is 0.01 over 2. Why? Because this is two-tailed, so divided by 2. Comma, our degrees of freedom is 19 minus 1. So which is equal to plus and minus 0.01. This is T. 0.01 divided by 2 is 0.005. You may use your calculator. And then 19 minus 1 is 18. Thus, our critical values here, 0.05 here, and we have 18 here. So we have 2.878. So this is now positive and negative 2.878. So these are our critical values. Okay, after this, let's have the computation T. The T computation, we have X bar, or the sample mean, minus the population mean, over the sample standard deviation, over the square root of n. What is the sample mean? So it is 17,350. Minus the population mean is, what did we use here? 18,000. So 18,000. Divided by, our standard deviation is 1,230. And square root of 19. So you may use your calculator again. That's 18,000 divided by 1,230 divided by square root of 19. So the answer here is negative 2.303. Negative 2.303. Now let's examine for our decision. This is two-tailed. So we have the left tail and the right tail. The left tail, we have the critical value negative 2.878, negative 2.878. And for the right tail, we have 2.878. Now, let's locate our t computed. Okay, t sub c. It's negative 2.303. So it is somewhere here. So therefore, what is our decision? What is our decision here? What is our decision? Our decision here is do not reject HO since the T or T computed does not fall within the rejection region. So that is our decision. Now, what is our conclusion? Conclusion. So our conclusion is, let's look at this, do not reject, so it's equal to 18,000. So you may conclude that the undersecretary's claim is correct, or the average salary, wait, content code, the average salary of civil engineer is 18,000. Okay, since HO is not rejected, so we will conclude this one, 18,000. So the average salary is 18,000. Now number 4. Powdered milk is packed in 1 kilogram bag. An inspector from DTI suspects that the bag contained less than 1 kilogram. A sample of 40 bags produces a mean of 0.96 kilogram and a standard deviation of 0.12 kilogram. Is there enough evidence to conclude that the bags contain less than 1 kilogram as stated at 0.05? Now, again, let's start with our alternative and null hypothesis. Okay, is there enough evidence to conclude that the bags contain less than? So this is less than. So meaning this falls on the alternative hypothesis. So less than 1 kilogram. Therefore, our null hypothesis is greater than or equal to 1 kilogram, or again, you may use the equal symbol. Either of these two will do. Next, the alpha, it's given 0.05. Next, is it a Z or a T test? So let's examine. N is 40. With this alone, we can conclude that this is a Z test because N is greater than 40. S is given, the sample standard deviation is 0.12. But since N is 40, this is a Z test or Z distribution. Now, is it left-tailed, right-tailed, or two-tailed? Let's go back to our alternative. It's less than, so this is a left-tailed test. So left-tailed. Thus, what is our critical value? Our critical value is negative Z sub alpha. Okay, Z sub alpha, and it's negative, and the alpha is 0.05, is 1. Okay, so we have negative 1.645. That is our critical value. Next, let's compute for our Z computed. X bar, or the sample mean, minus the population mean, divided by, we are given with a sample standard deviation and square root of n. X bar is this one, a sample, a mean of 0.96. Our population mean here is whatever is used in the hypothesis. We have 1 kilogram divided by S is 0.12 square root of 40. So you may use your calculator. Divided by 0.12 divided by square root of 40. So this is negative 2.11. So our Z computed is negative 2.11. So our critical value is negative 1.645. So let's draw for us to make a decision. So we have 0, negative 1.645 is here. And this is our critical or rejection region. Then we have here the computed negative 2.11. So take note, the Z computed falls within. It falls within the critical or rejection region. Therefore, what is our decision? Reject the null hypothesis since the Z computed falls within the rejection region. Okay, so that is our decision. Now, the last part is, of course, our conclusion. Conclusion. So, reject HO. Reject HO. So, we have less than 1 kilogram. So, you may say that therefore, the bags of powdered milk weigh less than 1 kilogram, or there is sufficient evidence to conclude that the bags contain less than 1 kilogram. Okay, since we reject HO, so we will conclude the alternative hypothesis. Next, number 5. A researcher claims that 20-year-old women on a special diet will have an average weight of 110 pounds. A sample of 15 women has an average weight of 112.5 pounds and a standard deviation of 5 pounds. At 0.01, can the claim be true? So the claim is stated at the first sentence. So we have the null hypothesis and the alternative hypothesis. So the claim is that 20-year-old women on a special diet will have an average weight of 110. So meaning this uses the symbol equal sign. So this is, or this falls on the null hypothesis. So 110 pounds. Next is, since that is equal sign, of course, or the symbol here is not equal. So the average is not 110 pounds. So these two now are our hypothesis. Next, our alpha. Alpha, this is 0.01. Okay, it's given here. And next is it a z or a t-test? So let's have n, or let's examine. N is 15. And we're also given with a sample standard deviation, which is 5. So this means that this is a t distribution. Now, is it a two-tailed test or a one-tailed test? Now let's examine. Let's look at this. This uses the not equal sign, so this is a two-tailed test. So it has no direction or non-directed hypothesis or direction. Two-tailed test. So therefore, the critical values here are the plus and minus t sub alpha. What is our alpha? So 0.01 over 2, comma, the degrees of freedom is 15 minus 1. This is parenthesis. So which is equal to plus and minus t sub 0.01 divided by 2 is 0.005. And 15 minus 1 is 14. So we have again 0.005. Then we have 14. So we have 2.977. So this is plus and minus 2.977. Okay, so we have the critical values. Next is to compute for the t computed. So we have x bar minus the mean divided by s divided by square root of n. So x bar, the sample mean is 112.5 minus the mean here is 110. So always look at the hypothesis for your population mean. And then s is 5, the standard deviation is 1, divided by n is, or this 15, so square root of 15. So you may use your calculator. 112.5 minus 110 divided by 5 divided by square root of 15. So we have 1.936. 1.936. So let's draw. So what are our critical values? We have negative 2.977 and positive. So 2.977 and positive 2.977. Now let's locate positive 1.936. So it's somewhere here. 1.936. So what is our decision? Our decision here is do not reject, or you may simply say accept HO. Do not reject HO since the T computed does not fall within the rejection region. So it does not fall within the critical region. So the last one is to make our conclusion. So since we will not reject HO, so we may simply say this one. The "20-year-old women on a special diet have an average weight of 110 pounds." Or you may say that there is no sufficient evidence to reject the claim that the average weight of women is 110 pounds. So you may choose between the two. But the easiest part here is, of course, you may use your HO or HA for your conclusion. So meaning, since we will not reject HO here, so you may conclude HO directly, meaning that the average weight of these 20-year-old women who has this special diet is 110 pounds. Last, the average family size in the Philippines was reported as 4.25. A random sample of families in a particular street resulted in the following sizes. We have 5, 6, 7, 4, 3, 8, 2, and 9. At alpha 0.10, is the average family size more than the national average? Now let's start with the alternative and null hypothesis. Now let's look at this. Is the average family size more than? So meaning it uses the symbol greater than. So meaning this is our alternative hypothesis, or this falls on our alternative hypothesis. So national average is 4.25. So greater than 4.25. Null hypothesis, of course, is the opposite, less than or equal to 4.25, or you may simply use the equal sign. So either of these two. Next is the alpha. Alpha is given at 0.10. Next, is this a Z or the t-test? So let's examine the n and the standard deviation. Okay, the n here is, we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 families. And of course, since we're given with a sample, so we can compute for S. Okay, so S, if you compute for S is equal to 2.45. So you may check this one. Okay, the S here is the 2.45. So you may use the equation sample standard deviation is the square root of the sum of x minus x bar, the quantity of this, and then square divided by n minus 1, since this is a sample. So you may recheck that S is 2.45. Now we have n equals 8 and the sample standard deviation is given. So this is a t-test. Okay, this is a t-test. Now, is this a two-tailed test or a one-tailed test? Now, look at this. This is a one-tailed test, specifically a right-tailed test. Right? Since this is greater than. So, therefore, our critical value or CV is positive T alpha. We will not divide this by 2. Okay, because this is one-tailed. So, it is just alpha, which is 0.10. Comma, the degrees of freedom is 8 minus 1. So, we have T 0.10, comma, 7. So, we have 0.10. So, this one, the first column or the second column, I mean, and we have the the 7 as our degrees of freedom. We have 1.415. So this is now positive 1.415. Okay, that is our critical value. Next is we need to compute the T computed. T sub C, or for the T computed, we have X bar minus the population mean over S divided by square root of N. Now, you may check that X bar is equal to 5.5. Okay? You just add 5 plus 6 plus 7 plus 4 plus 3 plus 8 plus 2 plus 9 and then divide it by 8. Okay, so just compute for the X bar. Now for the population mean, okay, by the way, I will substitute this here, 5.5 minus the population mean is here in our hypothesis, 4.25. Okay, and we have the sample standard deviation. What is the sample standard deviation? It's 2.45 divided by square root of 8. There are 8 values. So you may use your calculator. 5.5 minus 4.25 divided by 2.45 divided by square root of 8. So we have 1.443. 1.443 positive. So next is the decision part. So first we have to compare the Z computed and the critical value. The critical value is 1.415. So somewhere here, 1.415. And our T computed is somewhere here. So by the way, this is our critical region or the rejection region. So somewhere here is our T computed 1.443. So what is our decision? Our decision here is to reject HO since the T computed falls within the rejection region. So it falls within the rejection region. So therefore, that is our decision, reject HO. Thus, our conclusion, if we reject HO, you may simply conclude the alternative hypothesis that the average family size is more than the national average. So you may simply say the average family size is more than the national average, which is 4.25. Okay, since we rejected HO, so you will, or you may conclude, or you will conclude the alternative hypothesis.